Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraiman Khaliesah binti Kamal Baharin. I am the group leader and I am the first presenter.
Assalamualaikum warahmatullahi wabarakatuh. I am the second presenter. My name is Nadzatul Hajar binti Mhd Nizam.
Assalamualaikum. My name is Syafiqa Emylyana binti Mhd Nazri. I am the third presenter. For abstract, this study used fuzzy semi method and hierarchical method in clustering the dataset of electricity consumption to determine the typical consumer electricity load profile. This study presents double clustering of fuzzy semi and hierarchical clustering method, where we cluster the dataset first using fuzzy semi, and to get more accurate result, we clustered it again using hierarchical clustering method. In the study, we use three types of index to determine the compactness of resulting cluster and to find the optimal number of clusters. The findings from the study will help to analyze the demand profile of consumer electricity consumption in different energy sectors that located in Ternicity, Italy. From this study, number of cluster 3 is chosen as the optimal number of cluster by double clustering, and it is proven that double clustering is more reliable than single clustering.
Through all these years, electricity consumption data have been widely used in creating electricity load profiles and providing electricity usage information over time. As it has been widely used, electricity providers and consumers must realize it is important for them to see the pattern of the electricity consumption to avoid any electricity wastage. One of the ways to avoid this electricity wastage is by the determination of typical load profile using double clustering. Load profiles are used as they are significant files that collect measured data on different substations for electricity consumption, and various data are collected, which is very important for electrical companies. Typical load profiles are load profiles that represent the common type of electricity profiles, such as residential, commercial, or university. It is important for suppliers to study typical load profile to avoid electricity wastage due to supplying extra electricity power to consumers and help the supplier from undersupply. There are a lot of clustering methods that can be used for determination of typical load profiles, such as K-means, FCM, fuzzy C-means, hierarchical clustering, self-organizing map, support vector machine, subspace clustering, and etc. However, in this study, we will use double clustering of FCM and hierarchical clustering. The proposed FCM and hierarchical clustering method is expected to create informative and representative electricity consumers profiles, which enable electricity suppliers to control the electricity supplement to consumers. In this study, the typical electricity load profile in Ternicity, Italy is determined in order to utilize the electricity consumption.
As for our problem statement, we have two problems that involved in this study. Firstly, problem in fuzzy K-means that make we choose FCM as our method. Basically, FCM is an improvised method of fuzzy K-means. Therefore, we choose FCM as our method because FCM have solved all the problems that involved in fuzzy K-means. And secondly, problem in FCM. FCM, or we call it as fuzzy C-means, cannot stand alone when we cluster the data due to some limitation involved in the FCM. Therefore, we attach hierarchical clustering as our second method in order to get more accurate result and as an improvement of FCM.
There are three objectives of this study. The first one is to obtain the typical baseline load of consumers' electricity load profile by using fuzzy C-mean and hierarchical method. The second one is to validate the fuzzy C-mean clustering result by using cluster validity index, which are Davis-Baldwin index, Kalinski-Hara-Base index, and Silhouette index. And the last one is to validate the hierarchical clustering method by using the same cluster validity index as used in fuzzy C-mean. Scope and limitation of study. The study focused on obtaining the typical baseline load profile of consumers' electricity consumption in Tennessee, Italy by using fuzzy cement and hierarchical clustering method. The study used 270 electricity consumption data from Tennessee, Italy due to the confidentiality of data from TNB in Malaysia.
The significance of study is this study will redound to the benefit of electricity providers in managing the load requirements in certain places in Malaysia using double clustering method of fuzzy cements and hierarchical clustering. Electricity providers will know how much they should provide to consumers, and consumers will know how much consumption that have been used. And both electricity providers and consumers will minimize the electricity wastage.
So these are literature review that are used in load profiling, fuzzy cement, and hierarchical clustering method.
As for our methodology, these are our research framework. There are 5 phases involved in our methodology, which are the first phases is the data preparation, and the second phases is the first clustering, which are fuzzy cements, and the third phases is the cluster validity analysis for FCM. And then the fourth phases is the second clustering, which are hierarchical clustering. And lastly, the fifth phases is the cluster validity analysis for hierarchical. And then our double clustering is complete.
That is result and discussion. For fuzzy cement clustering, we have clustered the data into 3, 4, 5, and 6 number of clusters. The simulation is done for us to find the optimal number of clusters, where we use 3 types of cluster validity index, which are Davis-Bode index, Khaliesah index, and silhouette index. This simulation also done for us to find the stable number of cluster, where we can see it where the cluster number is unchanged even when we change the number of clusters. For the evaluation part, for Davis-Bode index, number of cluster 5 is chosen as the optimal number of clusters since its criteria value is the lowest among the others. For Khaliesah index and silhouette index, number of cluster 3 is chosen as the optimal number since its criteria value for both index is the highest among others. Since that 2 of 3 cluster validity index shows that number of cluster 3 is the optimal number, therefore the optimal number of cluster for fuzzy cement clustering is number of cluster 3.
After fuzzy cement clustering, the output of FCM will be used as the input in the hierarchical clustering, which is the number of cluster 3. This figure shows the simulation results for the typical electricity load profile for number of cluster 3 until 6. The simulation is used to find the optimal number of clusters. The number of clusters are stopped at 6 because the higher the number of clusters, the optimal number of clusters suggested still remain the same, such as when the number of clusters 8 or 10. This means that the optimal number of clusters are still at the cluster 5. The simulation results are then applied in the 3 cluster validity indexes to find the optimal number of clusters. Firstly, from figure 4.4.1, we can see the optimal number of clusters in Davis-Bode is at the point 3, 0.8757, which is at cluster 3. Based on figure 4.4.2, the optimal number of Khaliesah index is at the point 3, 573.8815, which is at the cluster 3. while figure 4.4.3 shows the optimal number of silhouette index is at the point 3, 0.9061, which is also at cluster 3. So by identifying all the criterion values for each index, the optimal number of suggested by all three indexes are the same in which cluster 3 which is chosen as the optimal number of cluster.
As for discussion of the result part, as shown here, these are two graphs of the result of typical electricity load profile by using double clustering method and single clustering method. These two graphs have the difference, which are, as we can see the C1 in the single clustering result, we also can see the same pattern as the C1 in the double clustering result, which are in C2, while the C2 in the single clustering result, we also can see the same pattern at the C1 of the double clustering result. These are the difference between these two graphs. Based on the double clustering method result, we can conclude that C1 represent the typical electricity load profile for industrial area, while C2 represent the office area, and lastly, the C3 represent the commercial area. As shown in this table, these are the criterion value for cluster validity indexes for double clustering method and single clustering method. For Davis-Baldwin index, the minimum value will indicate the best clustering method, while the other two cluster validity indexes, the maximum value will show the best clustering method. As we can see here, the double clustering method is chosen as the best clustering method when compared to the single clustering method by observe the value of the cluster validity indexes, as we can see here.
Fulfilling the first objective, this study uses double clustering of FCM and hierarchical clustering to obtain typical baseline of consumers' electricity load profile and has overcome the problem arise in limitation and accuracy of FCM result. Fulfilling the second and third objective, this study validates FCM and hierarchical methods by using three cluster validity indexes, for which are in Davis-Baldwin index, Kelvin-C-Harabes index, and silhouette index, that give different values of indexes to choose the optimal number of clusters, and also to prove that double clustering method is more appropriate to use compared to single clustering. So it has successfully given more appropriate results, and the results show that the double clustering method could divide more than 200 daily data of electricity consumption into three groups, which are industrial area, commercial area, and office area, and obtain their typical electricity load profile for each group.
Last but not least, as for recommendation section, we have three recommendations for this study. The first one is similarity measure. Similarity measure test can be done in the future for this study as for validation purpose, in order to support that double clustering method is more appropriate than single clustering method. And the second one is this double clustering method also can be done by using hierarchical clustering method as the first clustering method, and then followed by FCM as the second clustering method. And the last one, which is the third recommendation, is other than cluster validity indexes that have been used in this study, we also can use other cluster validity index for validation in this study, such as Seabeny index, Dan index, and several other cluster validity indexes.